Everyone, thanks for joining us today. We are here to talk to you about Terraform on Azure and some of the things that we have been working on and want to share with you. We attempted this same community call a couple of months ago and had a whole bunch of technical issues. So we will essentially be redoing a lot of that content and updating it with some of the information that we've added since the 2 months that the team's been working on. So to start, my name is Mark Gray. I am the Principal Program Manager for Terraform on Azure, and Stephen is here with me.
Hi, I'm Stephen. I'm also a Product Manager for the Terraform on Azure experience.
Awesome. So I'm going to kick us off and talk to you about give you a quick overview of what we'll be talking about today, and then hand it over to Stephen and go from there.
And I'll be taking questions from the chat. So if you send those in, I'll read them in as we're going. Thank you all.
Awesome. So I'll start out by just kind of reminding everyone there is a code of conduct for this. This is a Microsoft event. And we ask that you are essentially nice. I'm not going to go through all of the content on here, but don't be flaming other people or anything like that. So just ask your questions, even if they're hard questions, but do it in a good way. So we appreciate your interaction with us. All right, so from the agenda perspective today, we'll go over a couple of high-level things. Then we'll dive into two of the products that we have. The first one provides zero-day support for Terraform. So anything you want to do in Azure, you can do using this provider. And then we'll talk some about the Terraform export tool and what you can do with that. And then we have a section that we're going to be doing on a regular basis, but we want to talk about cool open source projects. So that have to do with Terraform and Azure. We have one that one of our internal folks, or not one of, a few of our internal folks have worked on that we asked to be here today, but they're in a different time zone and it just wouldn't work for them. So we actually met with them ahead of time and did a recording. So we will play that recording at the end so you can learn about that. And going forward in community meetings down the road, we will bring up other open source projects. So if you have any that you think might be interesting and good for others to know about, feel free to shoot them our way. And we'll kind of make sure that we touch on some of these, either one or multiple in each of these meetings. So, all right, so let's start out by just giving you an overview of who we are, what our team does, and why we care about Terraform and Azure. If you've heard myself or Stephen talk in the past, you probably have an idea about this, but it's good to kind of get the framework on what our team does, what our focus is, and what our commitments are. So we are part of a deployments team on Azure. And the deployments teams care about anything to do with the command line experience for Azure. So if you can use a command line to manage Azure, our team owns it. In fact, our team, a little bit broader part of our team owns the portal as well. So essentially, when you're managing Azure, our team owns that stuff. And the goal from our team is to ensure that you can use whatever tool and product you want to manage Azure. So whether you want to use ARM templates or Bicep or Terraform, you can use that tool and be successful and have a consistent experience across those things. Stephen and I focus on Terraform. So he and I and our team focus on Terraform, and we work on the Azure RM provider, as well as these other tools and things like that we'll talk about today. But it's our day-to-day job to make sure that you can be successful using Terraform on Azure. Our team also owns CLI and PowerShell. Just as a note, those are command lines that you can use to manage Azure, and our team owns that. So we really all work together to make sure that you can use whatever tool you want to manage Azure. And this community meeting is something that we will be doing, and we've started doing on a regular basis. We're going to do it every couple of months on average. And we value the community and want to make sure that we build and invest in tools that are important to the community. So we want to make sure that we have these calls that we can share not only what we're doing with you, but can actually hear back from you on if we're doing the right things, if we're not doing the right things, and what have you. So we really want to make this a regular occurrence and build the community so that we can know that we're doing the right things and you are getting what you need from our team. All of the products that we work on, by the way, whether they're Terraform or ARM templates or Bicep, are open source. So you can also contribute to the projects, and we can help you get things merged and things like that as well. So, all right, from there I will jump into the 0-day support and talk a little bit about that, what we're doing there, why you should care about that, and what that means from the broader Terraform perspective. Before I actually jump into that, one of the biggest pieces of feedback that we have gotten from customers over the years is they like Terraform, they like the experience of Terraform, they like the syntax of Terraform, but they have frustrations with being able to do everything they want to do using Terraform on Azure. We've heard that on a regular basis. We've invest every day to make sure that you have the coverage that you need to manage Azure, and we will continue to do that. So the Azure RM provider is something that the 90% of our engineering team actually spends their time on a daily basis, making sure that we have that coverage and you get that coverage. The 0-day support and our promise from the Azure RM provider perspective is when a service or a feature goes GA, within a short period of time, and a month or so, we will have coverage into the Azure RM provider for that. There are a number of scenarios that customers have where the feature is not GA, and they still need to be able to manage that with Terraform, and that's where this 0-day support kind of comes in. That's the sweet spot for this. Or they're just services that don't make sense for Terraform to cover, but you still want to manage those with Terraform. So we introduced the AzAPI provider, I want to say about a year ago, and it has the RTM version. So the 1.0 was released at the beginning of this year, the first quarter of this year. But the whole intent with this provider is to allow you to be able to manage, to use Terraform in the way that you expect to use Terraform. So you have a resource, you have properties in that resource, and you can manage that thing. Everything gets saved in state. So you know that if you change one property, Terraform is going to want to update that thing. So give you that full fidelity experience from a Terraform perspective, but not have to wait for the provider to be updated to support features and those kinds of things. This provider is a thin layer on top of the API. So if something's available in the API, you can do it in this provider. So it gives you that immediate ability to manage Azure in a Terraform-friendly way. Because it is a thin layer over the API, we didn't want to expose the API directly to you, essentially. We wanted to make the user experience easier, so we've added some tooling with the Visual Studio Code and language server and things like that. So you have a good experience. You get syntax highlighting and all of that kind of stuff with this provider. The last thing is we do expect customers to, when they use this provider, to move to the Azure RM provider when support is added to that. And we didn't want to kind of leave you out in the lurch with you using this provider and now it's supported in Azure RM. It's possible to move over there, so go ahead and do it. So we actually created a migration tool that streamlines the process and allows you to actually do that migration. And if you've heard some of these talks, we've shown that. We are continuing to invest in that and improve that. We've got some feedback on that experience, and we'll continue to invest in that to make sure that you can very easily move from the AzAPI provider to the Azure RM provider when you need to. Just to go over what we already have, this is not new, but in the AzAPI provider, we have a couple of resources. The full-fledged resource, which is the AzAPI resource, and then we have an update resource. The AzAPI resource is a resource that manages the full lifecycle of an Azure resource. So it manages the create, update, delete, and all of that kind of stuff. The update resource is intended to manage pieces of resources. So if you have an Azure RM resource, that does 90% of what you need to do, but there's a new feature that's been added and isn't supported in the Azure RM resource yet, you can use the AzAPI resource to actually manage those properties associated with that new feature and functionality. So it's not creating the resource, it's just allowing you to manage those properties, and then the resource can be managed with Azure RM as well. That's one of the scenarios for the update resource. But again, these have been there since the beginning. And what I want to focus on more today is kind of some of the new stuff that we added in 1.0 and things like that to this resource. So I'll go over a few of these and then give some demos on kind of what these are, so you have more context on why you would want to use them and those kinds of things. So the first one that we have added, and it's kind of the big piece of this, is the action resource. And the action resource allows you to manage everything that is not in a put request in Azure. So if you want to list things or get and things like that, you can do that with this action resource. So it really opens up Terraform so you can manage anything that's in the API. And I'll show you some good examples on when and why you would want to use that. The next thing we've done, and I will show you here real quickly, is added some really thorough documentation for the AzAPI provider. If you're familiar with Bicep, there is documentation on the schema for Bicep. So in the Microsoft documentation site, all of the resources and services that you can manage are in the documentation. And if you go into lab services, for example, you can see the full schema of the AzAPI configuration for a resource. So you can see all the types or all the properties that are supported, not only at the top level, but in the body itself as well. And you can see the resources that are, the properties that are supported and the values that are required for those properties. And then you get all of the information about what those properties are, what they do, and all of those kinds of things as well. So you have some really good documentation on all of the different types from a Terraform AzAPI perspective. So we're really happy with that, and we'll continue to keep that up to date so that you have the information you need to be able to manage those things. The next thing we've done is for the migration tool that I've talked about, we have actually created some packages for that. So if you're using Windows, we have an MSI package. If you're using Linux, we have an apt and DPI package, I think. But we have some of the major releases packages, so you don't have to worry about downloading a binary and figuring out how to set the path and all of that kind of stuff. The package will actually do that for you. So it just removes one more barrier on being able to actually do that migration. The next thing we have done is added the ability to ignore missing properties. So one of the things that happens with APIs, and this being a thin layer on the API, is you'll run into a scenario where you set a property, and a good example of that is a password. So you set a password and you pass in the value of that password, but then the API doesn't return that value because it's a secret. You can use this ignore missing properties property to actually ignore that. So this provider doesn't tell you that it needs to change every time you run Terraform plan or apply. The next one is a locks property, and this is kind of a special case, but it's really useful when it's needed. But there are some resource types that can only be created in sequence. They can't be created in parallel. So I'll show you an example of that. But if you have 100 resources that need to be created and they can only be created in series, then you can use this locks property to actually set it up so those resources don't have dependencies on each other, but they'll be created one after the other. And the last thing is we've spent a lot of time fixing bugs and making sure that the AzAPI provider works really well and really stably for you. All right, so from there, I will jump in and talk you through a few of the examples we have here. All right, so I'll start with one that many of you are probably familiar with because it's the #1 ask we have on the Azure RM provider. And it is having the ability to deploy a container app using Terraform. So in this configuration, I have a bunch of Azure RM resources that are supported by Azure RM and are prerequisites to the container app resource. So these are just standard resources that you would expect in here that are Azure RM resources. From the AzAPI perspective, I have 2 resources here. I have an AzAPI resource that is used to deploy the app environment, and then another one to deploy the container app itself. And a couple of things that I will point out here for you is the type here. If you have not seen this already, the syntax highlighting in the language server that we have here allow you to very easily learn what all of the different types are in that can be managed by the AzAPI provider. So you can easily discover those things here. So you get that. And if you select that and select the type, you'll see one of the things that happened here was the properties in the body became red underlined because the language server that we've implemented here gives you that information. So we know that this type is being created and we know the properties that are supported by that type. So we'll give you that information that these are not actually supported by this type. So you can get that full experience and very easily be able to author these things without having to go look at REST documentation or anything like that. The other thing that I'll mention here is that in this configuration for the managed environment, we have a shared key that we're passing in here. That is a secret, and the API is not going to return the value for that. So setting the ignore missing properties to true will allow this to configure correctly. And then when you run plan for the second time, it's not going to require you or tell you you need to change or there is a change and you need to apply another configuration. So it gives you the ability to have a clean plan and apply. The next resource is the container app itself. And in here, you can see all of the properties that are associated with the container app. And again, because I am passing in a secret here, I'm actually setting a secret that does not get returned. I will do the ignore properties on that as well. And just to show you here, if I come down and hit return underneath the properties, you can see that I get a good list of all of the properties that are supported in my configuration. So you just get a good authoring experience with the Visual Studio Code extension that we have here. I can show you here real quickly the extension. So it is a AzAPI extension. So this is the extension you would want to install if you're going to use the AzAPI provider. All right. From there, I will jump into so for the sake of time, I'm not going to run these installs, they do work, and it behaves just like Terraform. So you run this configuration, everything gets saved to state. If you make a change to any of these properties, Terraform will tell you that this property changed and needs to be updated, and give you that full fidelity experience from a Terraform perspective. The next example I'll go over here real quickly is so in this example, I'm going to use the action resource. So you can kind of see what the action resource is used for, or a couple of scenarios where you'd want to use it. In this particular example, I'm going to deploy a function app, and I want to set some app configuration information for that function app. And I'm going to assume that that's not supported in the Azure M provider. So here I actually use the Azure M provider to deploy a function app, and then I can use my action resource. So just as an FYI, because of the API, or the way the API works, you would think you can use a data source for the AzAPI resource and get the app config for that thing, and then be able to manage that way. But this actually doesn't return the app config values. It returns information about the app config. So the way that you would need to do this is to actually have an action resource here, and I'm going to manage the app config using the action resource. And I'm going to reference the app configuration from the data source here. So I'm going to get the app configuration from my function app here. And the way that I actually see all of the configuration that's in there is do a post and then do a list action on that thing. So I'm going to get, this is going to return the config data for the function app. And here I will output that so you can actually see what that is. And then I'll be able to augment that or add what I want to that. So this is a bit of a contrived example, but it shows how you can actually use the action resource to access functionality that would not otherwise be available in the AzAPI provider. And in here, you can see in the action resource here, I'm going to actually, for the last step, I'm going to take the information that is the config app data and add information to that. So the additional app data information I want to add, and I'm going to do a put on that. So I'm actually just going to update the app settings on the function app, and it's going to update that information for me. So it gives me the ability to do that. All right, so the next example here that I will go over real quickly, this is a interesting one because it solves a problem that's not currently accessible in Azure RM, and it's something that a number of customers want to do. So in this particular case, I am deploying a Kubernetes cluster, and the Kubernetes cluster under the hood has a bunch of VM scale sets for the node pools. So I want to be able to set a user assigned identity on those VM scale sets, and be able to use those instead of the system assigned identity. So I'll use the Azure M resource to create the Kubernetes cluster. I'll use the Azure M resource to create the user assigned identity. And then I will actually get the resource group that is generated by Kubernetes. So the AKS, when you deploy it, it creates a well-known resource group name and then deploys all the VMs and everything like that inside of there that it needs. So in this particular case, I'm actually using a data source and then putting together the well-known resource group name, and then I'm getting that resource group. So then I can actually use the action resource to get all of the VM scale sets. So the way that we do that in Azure in the API is to actually, on the resource group itself, I need to call this action, which will give me a list of all the VM scale sets that are in that resource group. And I'll return all of those. In this particular case, I know that there's only one that I'll be creating. So I can then use the action resource to patch the VM scale sets and add the user identity to that. So I'm actually replacing the system identity and adding the user identity to that. So it gives you again, just another example of being able to do whatever you need to do in Azure using this action resource. And this is a real example that we had a customer run into this, and it was able to unblock them and allow them to actually manage this very easily using Terraform. All right, so the last example that I will walk through, this will show the lock resource or the lock property that we have. So in this particular case, I'm going to create a routing table, and I'm going to create some routes inside of that routing table. And this API does not allow you to create routes in parallel on a single route table. So in order to do that, I don't want to tell a set of dependency between all of these routes. I just want to make sure that when they're created, they're not created in parallel, but they're created in series. So to do that, I use the lock property here, and then I can just reference a unique ID and have the same unique ID for each of the routes, and that will make sure that when Terraform runs, it only creates one of these things at a time. So it'll do all of the other typical dependency stuff that it does. But then in addition to that, when it's creating one of these routes, if it's creating route 1, it's not going to create route 2 and 3 and so forth. So it gives you the ability to actually make sure that these are created in a serial kind of way. So with that, I think that kind of highlights some of the new features and properties and things like that we've added to the AzAPI provider. And I will kind of touch on a few things here, just some questions that come up regarding the AzAPI provider. I touched on these mostly at the beginning, but I do want to be very clear that the AzAPI provider is not intended to replace the Azure M provider in any way. Our team invests in both of them. We invest heavily in the Azure M provider and work very closely with HashiCorp to ensure that we have good coverage in the Azure M provider, and we will continue to invest in the Azure M provider because we know that the Azure M provider is the kind of the polished experience that you all are looking for when you're using Terraform with Azure. But we do also know that there are scenarios where you will need another way to manage Azure, and we want to make sure that when you do that, you have a great experience, and the AzAPI provider will certainly help with that. Lastly, yeah, from this perspective, there's just a bunch of questions that we hear about the AzAPI provider, and I will kind of pick one of these at random and talk to it real quickly, so I'm not going to talk through all of them. Which one? So I already talked about the replacing some of the limitations of the AzAPI provider. It is, so the way that I talk about the Azure M provider and the AzAPI provider is, if you're familiar with PowerShell, PowerShell has a concept of convenience layer and essentially a direct reflection of the API. The AzAPI provider is a direct reflection of the Azure API, and the Azure RM provider is a convenience layer. So using the Azure M provider will be easier and more streamlined for you, but the AzAPI provider will allow you to do anything you want early, and that includes preview features and functionality, whether it be private preview or public preview. If it is exposed in the Azure API, you'll be able to do it. It is just a matter of being a little bit closer to the API, so knowing what post means and some of those kinds of things is something that you'll have to work through with the AzAPI provider. So it's just the limitation is that it's a little bit harder to use, but we're doing and we'll continue to invest in it to make sure that it's easier for you to use. So I will pause there. Are there any questions that have come up on the stream? Nope. No? Okay. All right. From there, I will hand it over to Stephen to talk to you about the Azure Terraform export tool.
All right. Can we hear me okay? We're staying on the same one for now. All right. So I'll talk a little bit about the Terraform export tool. You might have heard of this tool by now, but if you haven't, the name of the tool is currently in the works. We're just going to refer to it for the sake of today as the export tool. The main goal of this tool was and continues to be that we want to streamline the process for Azure customers. Basically, if you had something that was existing in Azure, but you weren't sure how you're going to convert that into Terraform, the whole point of the tool was to help streamline that process and get you going in Azure RM, whether you were new or experienced and just didn't know how a specific scenario worked. The whole original goal was we're going to specify at just the resource group level, but now we've added support for subscriptions. And excuse me, we plan to basically run the tool and you would be able to say Terraform plan and no changes needed without having to go into the code and modify anything yourself. So as we were developing this tool and talking to some of you within the community, we discovered that the original goals that I just mentioned in that previous slide were definitely things that you as part of our community felt were painful. But what, in addition to that, you felt was that there were other scenarios that you thought this might be able to help with. So in addition to taking existing Azure infrastructure into your own management, you were also talking to us about, hey, can we use this and convert it into code and then use that code to maybe compare with our own code as we're trying to learn to author an advanced scenario in Terraform. Or if we have a production issue, we don't want to mess with that code. So why don't we create a duplicate, deploy it to a sandbox environment? And why don't we use this tool to try to do that? And the last one was, hey, we want to create a module. We want to be able to more easily generate modules. And we took all of this feedback and we did what you wanted us to really make some changes. So I'm going to share with you some of the main changes to the tool over the past few months that, as of 0.9, we believe are really going to help you with those scenarios. So just give me a second to get set up on my screen. All right. Now it's muted. Sorry, my computer wasn't muted. That was what was wrong. It's good now. All right. So let's say that we were deploying something in AKS and we found difficulty to get it configured exactly as we wanted within Terraform. So what I went ahead and did is I went into the portal I configured all my settings exactly how I wanted it within the portal, and then I deployed that. Now that's great. And obviously you want to be able to use that within your production flows or within Terraform. So how would you do that? Well, what you could do is take this and directly move it into existing Azure infrastructure management. But let's say that you wanted to actually take a look at this HCL code that's generated through the tool and learn from it yourself. So the way that I would do that is I would go and type out AzTFY, which is the current name of the tool, and then I would use RG. The RG subcommand corresponds to exporting at the resource group level. And there's a few commands that you can use here, but for today's sake, we're going to specifically look at the subcommands non-interactive, which helps us just directly generate the code without having to load the UI mode that it normally runs under. The HCL only flag here is going to not export anything to an existing state, but it's just going to create the HCL files. And then we're going to use the full properties flag. And the full properties flag will basically help us expose properties that we might not necessarily have configured even within Azure Portal. So this will help with greater clarity in regards to what exactly is going on underneath the hood in your Terraform code translation of that Azure resource. Now, after we do all that, we just need to specify the resource group name. So in this case, we're going to specify that and then just run. And this will usually take a little bit. So for the sake of time, I'll go ahead and show a pre-run example. You'll see that all that was left was just the Terraform code. And you can also see that all of the code is generated with a bunch of properties that are normally set to defaults. Now, the one thing about full properties compared to your normal without full properties running is that you might need to configure the code to make it run with the no changes needed, but you get greater visibility into exactly how your code is configured. And that is really powerful. So I can go ahead and take this and I can start messing around with it and referencing it compared to my current attempts at a Kubernetes cluster authoring. Or maybe I can go ahead and use it as a module, and I can just convert some of these properties into a variables.tf, and then I would have for myself a module. So we really believe this is great functionality that'll help you with your scenarios. But at the core, we really want to still do a great job of supporting the moving existing Azure infrastructure into Terraform management scenario. And some of you were talking to us and said, hey, we want that to be done at a subscription level. And at first, we weren't able to support that, but now we are able to. And I'll give you a quick demo right here of exactly how we do that. So we have this new mode that we've added called Azure Terrafy Query Mode. Now, the query mode enables us to, excuse me, basically specify with where predicates within Azure Resource Graph, what we're exactly looking to export. So in this scenario, we have a resource type of managed clusters. And if you know what that is, that means that we're going to try to export all of our Kubernetes subscriptions or all of our Kubernetes clusters within our subscription. Now, I've set the subscription off screen, but you would have to do that yourself before you run this code yourself. And then there's this -g over here. This -g is a command for generate. What we're actually generating is a mapping file, which we'll go ahead and take a look at in a second. Apologies, I ran this earlier, so I'm going to use -f for overwrite. So once that finishes running, we'll go ahead and look at the generated mapping file. Oh, that did not happen earlier. Okay, that is okay. We will skip that for now. But what should happen, but what didn't happen, is that something along these lines, a mapping file, gets generated from the subcommand, and that will be able to then be consumed through a -m. So you would then do AzTFY, and there's a map subcommand, and you would take your existing path to your mapping file, pass that in, and it would export. Now, the nice and powerful thing about that, and what I wanted to call out here, is that you could actually specifically export all of your compute resources, all of your networking resources, all of your Kubernetes resources individually in your subscription, and then group them under a compute folder, a networking folder, a managed clusters folder. And from there, you would be able to export exactly how you want. If you wanted to exclude anything, you could just go ahead and delete one of these and exclude it from the export. So we really want to give you a lot more power and a lot more customization ability with regards to the tool. And we're hoping that through these scenarios, you are able to better do what you need to do. All right. I will go ahead and open this PowerPoint. All right. So now we have better support for your use cases. How have we exactly done that? Well, I just showed you that we can now use some scripting to batch migrate your resources. Full properties gets you accurate HCL code, and HCL only lets you feel enabled to use your HCL code as purely a reference. Now you can, as I mentioned before, refactor your resource group of subscription into the specific resource types. And you can just tweak your hard-coded strings into variables for an almost module. So we're really happy that we're able to introduce all of this functionality in 0.8 and 0.9. Some other changes that we have made over the course of this period was, in addition to the querying, there's no longer a limit of 200 resources when you export on a resource group. The mapping file, if you are an earlier user, you'll notice that we moved it to now be a bit more readable. And then for the resource mapping, one thing that happened in 0.6, but we want to repeatedly call out, is that the tool now can identify ambiguous resources, such as a Linux virtual machine and Windows virtual machine. And it can also identify associated resources, like a data disk for a VM. And it can also output for us whether there was an undefined resource. So with all that in mind, we did want to talk briefly about the roadmap for Terraform on Azure as a whole. And these are likely some of the themes that you'll see recurring during the community calls in terms of projects or things that we're working on. First, we want to make sure that our API coverage is great. We want to make sure that all of the Azure APIs that are important to your scenarios are covered by the Azure RM provider. Second, we want to continue to work with the HashiCorp team to create Azure RM resources and schemas that utilize the underlying SDK so that Azure RM remains a great and high quality provider. And we're always looking to improve that. The third thing is that we are continuing to work on our verified modules, and hopefully the next community call will have some updates for you on some of that work that we've been doing. And these two that we just talked about, the template export and the day zero resource support, these are our two of our big investments. And lastly, documentation. Mark showed you some of the great documentation we've added for AzAPI, and we're always looking to improve our documentation as a whole for the Azure Terraform experience. So our last section for today is talking about some cool open source projects, and this is something that we will have recurring during these calls. We just want to make sure to shout out some unique ideas or projects that could help enable your scenarios and help you have an easier experience for Terraform on Azure. For today, we are going to specifically talk about NoobsGen. NoobsGen is a tool that was created internally by some Microsoft folks. That's the URL right there for the project. And it just helps you generate some templates for your Terraform projects. And that we actually weren't able to have Christopher, one of the guys who worked on this, make it, but we did record a talk with him that we're going to go ahead and play.
Am I saying that? Am I saying that? Am I saying that?
Sorry, give me a sec. Turn this mic off.
Why don't you talk to us about Why don't you talk to us about what Why don't you talk to us about what NoobGen is? Am I saying that correctly, by the way?
Yes.
NoobGen? Okay.
Yeah.
So talk to us a little bit about what NoobGen is and why you all put it together.
Yeah, sure. So as a cloud advocates, we do a lot of demos, obviously, or learning exercises like workshop, etc. And for the use cases, we need to sometimes spin up an entire Azure architecture. Like we need to spin up a web app and a database and some Azure storage and maybe some cache, maybe some networking things, just to be able to show something very specific. And we used to spend a lot of time spinning all this infrastructure just because we needed to showcase what we want to showcase. And at the same time, one of our goals as a cloud advocates is to meet developers where they are. So we meet with developers in the startup ecosystem or in the enterprise ecosystem, and they kind of have the same needs. They are developers mostly, so they are sometimes having a little bit of knowledge about DevOps, sometimes nothing, and most of the time they have a very little knowledge about infrastructure. What they want is they just have an application. Most of the time, at least at the beginning, it's a very simple architecture, and they just want to host it on Azure, just to play with it, or just because they know it will be their target for deployment. But they want to do it today. They don't want to spend a week going through Microsoft Learn modules, learning about the platform. What they want is like right-click deploy, if I can say so.
Makes sense. All they know is they want a 3-tiered app that they want deployed and to put their code on.
Yeah. That's why we've created NoobGen. Our idea was to offer a simple experience to go from your code to your code hosted on Azure, but with in mind, because Julien and myself were both the creator of NoobGen, we already handle in your past experiences large-scale production systems. So we went through the pain of maintaining the same piece of code for like 5, 6, 7 years. So what we wanted to do is to offer like a shortcut experience to go on Azure, but still laying the ground so you can grow with that landing, with that shortcut experience, and not being like a single instance thing. You deploy that thing, and then if you want to grow your architecture, add new services, etc., you have to rebuild everything from scratch.
Awesome. That sounds great. So is there something you can show us here?
Yes. Let me share my screen.
Awesome.
So NoobGen come in different flavors, if I can say so. One of the easiest way to get started is to go on noobgen.com. So it's our website where we host an instance, and there you can have access to the NoobGen UI, where you will be able to basically build your application with very simple choices. So let's say my project is Hello Terraform. We support Terraform as our is not even a first-class citizen, because we built the first version of Terraform just of NoobGen just supporting Terraform, and later on we added Bicep. You can select your region. We don't have all the Azure regions listed, but we have some of them. The idea behind it is maybe in NewGen, we don't offer something that covers 100% of your exact scenario, but if we offer 80% of your scenario and then the 20 remaining percent are easy customizable, then it's okay for us. So region is a good example. We don't list all the Azure region and Gov Cloud region and sovereign region, etc. But you can easily change them if you want to use some specific region. Then you select your application type. For now, we are supporting web applications, serverless, and Spring Boot apps. But in the future, we are looking to add more compute type. You select your framework. So here I will just use a Docker with a Docker file, which is like almost any project can be packaged at least with Docker. But if, for example, you're choosing Spring Boot or .NET, we will be doing neat things like if you're in .NET, you're probably using Entity Framework as a way to access your database. And if you're in Spring Boot, you're using another tool. And these two different tools don't have the same default for example, environment variables that contain the connection string. So when you choose these kind of frameworks, we will not only change the configuration of the compute role, but also change all the settings so it can work with your framework.
Awesome. I love how you have the descriptions there so people don't have to figure out what a web app is or anything like that. They can actually see that information right there. That's great.
Yeah. And for example, we are looking to add like Azure Container Apps and Azure Static Web Apps. And for example, for Static Web Apps, what we have in mind is just say it's a static website. And where we are showing the Azure service behind it. Like here, we are saying, hey, it's Azure Function. So if you heard about it, it's Azure Functions. But if you don't know Azure Functions because you're just getting started with Azure, and you know you are building a serverless application, you know that it's the right option for you.
Yeah, that's great.
Same thing with the tiers. We don't have all the tiers, but obviously because we will. I didn't say it right now until now, but NewGen is actually generating the code, the infrastructure as code. So when you finish that little wizard, we will have a bunch of Terraform file or Bicep file or even GitHub action files. So obviously, in the Terraform file, you have some parameters. We create some modules. We will see them in a minute. And you will be able to tweak the app size, for example. So let's go with basic. I can add a database. Let's go for PostgreSQL. We have a bunch of add-ons, and we will add more in the coming months. So, for example, Azure Key Vault for storing all your secrets, Application Insight, and Azure Monitoring for monitoring your application. And we can do even things like a network configuration. So here I mean the default configuration, public, which is what you get by default on Azure and also what you get by default on a lot of other providers. But if you're just switching to virtual network, suddenly we will put your Azure Key Vault, your Azure Blob Storage, your database into a VNet. So you will not be able to access it from the internet. And we will connect that VNet right into your web application. So your code will be able to access all these resources, but not the internet. And it could be, it could be quite difficult to do if you're just getting started with Azure, and especially if you're just a developer, because you need to understand what a VNet is, what a subnet is, how do you connect these things with the different services.
Permissions.
Exactly. And we are doing all of this for you.
Great.
And then you can just download the zip file with all the coordinates. So as you can see, I have my Terraform files and I have some modules. So each service, we actually create a module per service. You can reuse that code across different configuration and deployments, or you can also just curl it. So if you, like me, you like your command line. Yep. I have an SRC. Yep. And I can do this. And I can do this. Export.
So are you showing a command line here? I'm not seeing it.
Oh, you're not seeing my terminal? Are you? Oh, it's weird.
I'm just seeing your web browser.
Oh, interesting. Sorry for that.
Hmm.
I was sharing my screen, so it's weird. Can you see
Oh,
it
there it
now?
is. Yeah.
Oh, okay. Sorry for that hiccup. So I just copy paste the curl command in here, and as you can see, there is all the parameters I choose in the wizard. So region, North Europe, application type, runtime, database, add-ons, etc. So you can even automate calling NewGen, or what you can do, and that's also something that is really interesting. If you are using Git, you will commit that thing, all of that code into your Git repository. And let me show you a repository I've done earlier. We also, in the Terraform folder, generate a README. And here you have the curl for actually regenerating the same configuration. And it's useful because if you now, like as you can see here, I only have the application insight add-on. But if I want to add a new component, like add a blob storage, I can just copy paste that, add blob storage here, regenerate, and then Git will automatically do the diff on my Terraform modules and my Terraform main.tf file. And then you can use NewGen on the same project in the long run to add new services or to move regions,
Okay.
for example. Or it happened like a year ago. We fixed a security issue in our Terraform file, and we improved the way we were handling environment variables declarations in NewGen. And so if you want to have the latest version of our code, because we maintain all of this Terraform code, then you just have to re-execute that to get the latest version of the code we generate.
Awesome.
When you've done that, you need to deploy it. So you can just do Terraform init and Terraform deploy. Apply, sorry. I've used another
Awesome.
command line all day, so
Yeah.
I'm
While that's running, I noticed you had the GitOps option in the UI.
correct.
What does that do?
So using Terraform that way is okay, and it's probably sufficient if your developer were just trying to understand Azure and try to run your code on Azure, etc. But as long as you want to do production things, it's probably not a recommended way, because I think everybody knows it here, but in this case, the Terraform state will be hosted locally, which means that if I want to deploy the same infrastructure from another device, or if one of my colleagues want to deploy fix or something, it will not work. You will have to share the Terraform states in another way or do other tricks. So because one of our assumptions for NewGen is all your code is into a Git repository, we want to offer you a seamless experience to go from your Git repository to Azure. So when you check at GitHubs, we will do a few things, and let me show you in that repository I've created earlier. First, we will change a few things in the Terraform configuration to not rely on a local Terraform state, but to rely on an Azure storage account to store the Terraform state. So you can run this from any number of computers, or in our case, from CI/CD agents. The other thing we are doing is we are creating the GitHub workflows for you. So this code gets automatically deployed when you push a change. So as you can see, if I go to my Actions tab, I've made a commit here, and it actually build my code, deploy my infrastructure with Terraform, and then deploy my code on that infrastructure. And in a display information task, I have all the information I need. So resource group, app name, and obviously the address, the HTTP address of my application deployed. This is deployed on a free tier, so it will take a few seconds to load the first time.
So with that, using the Azure RM backend, does the user have to go set up that storage account themselves?
Yeah, that's a great question. Indeed, you have to set up a few things to get this work. For example, in GitHub, you have to configure some secrets, like the Azure credentials. So Azure CLI and Terraform from the GitHub CI/CD can connect to your Azure subscription, and you need to inform Terraform about which storage accounts you need to use to store that. You can do all of these things manually, but if you are doing them manually, then you probably already know Azure. Or you can use the CLI. And actually, if you click here to download the things, you can go to the documentation. And what we created, it's listed here. We've created a small command line interface. So let me. I have some folder where I've done a demo. Hello TFOps. And then I can run GitOps. So we created a CLI. Don't be afraid. Here I'm calling the Java one, but there is like a native installation for Linux, macOS, and Windows. So you don't have to have Java installed on your machine to actually run this. As we compile it natively. I'm just using a debug version here. And what we are doing in this CLI is we are doing everything for you. So as long as you have the Azure CLI installed and you're logged in the Azure CLI locally, and you have the GitHub CLI again installed and you're logged in into your GitHub account, you can just go onto the directory that hosts your Git code and run newgen CLI GitOps, and we will do everything for you. And just to give you a sample of the things we are doing to simplify your life is here I'm in the Azure portal where I've already deployed 2 environments, a production environment and a development environment. And when you click here, we are doing things like having a tagging strategy. So we automatically create like an application name tag, an environment tag, and even a Terraform storage accounts tag, which lists which storage account hosts the Terraform state for that resource. So if we do a little search on it, we will find the storage account that contains VTF state for that specific resource. Oh, I'm not authorized, but it's here.
Oh, that's great. That's cool. And can people actually use that tool without using NoobsGen to kind of get their environment set up to use the Azure M storage?
So it's a good question, and I would say if any of the viewers have this need, please go to github.com/Microsoft/NewGen and open an issue. We are looking at this issue. We already have these asks, and we are willing to implement it. It's not a big deal to implement that. The only assumptions we have today is the name of the GitHub secrets. They are hard coded. You don't have a way to say when you use NewGen GitHub, say, hey, I want my TF, the name of the storage account, not being stored in that secret, but in this name. And you cannot rename a GitHub secret. When it's created, it's created. You can only delete it. And the other thing, which is kind of hard coded right now, is the name of the storage account we create is st and then a long random string. But if you have some requirements about that, you cannot like specify the name yet in the CLI. But as I said, it's easy to implement. There is in the NewGen GitHub CLI, there is nothing really specific about NewGen except these naming conventions. And it will be easy for us if people have the need to like create a new argument in the CLI so you can override them if you want.
Cool. Well, that's some awesome stuff. And you guys have done some really cool work to help developers actually use Terraform without even really knowing it. That's pretty awesome. So what's next for NoobsGen?
What's next? First, we want to make so NoobsGen is an open source project from day one, and we already receive a bunch of contribution and a bunch of GitHub stars. So don't forget to star the project if you like it. Yet, even if it's an open source project, if you want to add a new service into NoobsGen as an option, it's kind of complicated. You need to understand the templates, you need to change some Java code, etc. So we want to really simplify this experience of someone adding a new service into NoobsGen. And we have a ton of services we would like to showcase in NoobsGen. Azure Communication Services for sending in text messages and email, Azure Signaler or Azure Web PubSub for creating like real-time application. There's a ton of services we want to add. So that's the first thing. The second biggest thing we want to add is create a little more complex architectures, especially if you're using serverless. Right now, you can only have one type of compute and one compute. But if I want to have a web app and a serverless function that reacts to blob storage new files or to incoming webhooks or something like that, right now in NoobsGen, you need to generate two things and like do the mapping yourself. So you need to edit the code yourself. What we want to add in the near term is an ability to say, hey, I want a new compute and have maybe one web app, two serverless function, and one container instance, for example, in the same project, in the same application. And the last huge focus for us will be to raise the bar in terms of the production quality level of what we generate. For example, I haven't showed it, but with GitOps, you can create as many environments you want just by creating a branch in GitHub, but it's called env dash the name of your environment. Yeah. So to create like dev and prod, I just had to create two new branches. We want to provide more values to that. For example, we want to be able to, when you're creating a production quality branch, we will generate logs for you, so you don't accidentally delete your environment. We will collect logs in maybe an Azure Monitor resource that is hosted elsewhere, because you have like, maybe you have DevOps that want to aggregate all the logs into a specific instance. Maybe you want to have Azure Security Center correctly configured for all your production resources. So trying to, like, if you're on a prod-like environment, do generate more things, basically.
Yeah. That's awesome. Cool. Well, that's really good stuff. And I'm sure folks can go to noobgen.com and learn more about it. Go to the GitHub repo and contribute or open issues or what have you.
Yeah.
So I'm really excited about what you all are doing and looking forward to kind of seeing more of what's coming. So thank you very much for your time. And we will be talking to you soon. All right. With that, we will finish up, and thank you for joining us today. And hopefully you'll join us in the next community call in a couple of months. Hope everybody has a good year end and happy holidays, and we will see you next year. Thanks, everyone.